port is open circuited, that is I1 equal to 0. Okay, so in the figure A and figure B, in figure A we are calculating the ratio V1 by I1, that is the input impedance. In the second diagram we are calculating the output admittance, output impedance V2 divided by I2. Okay, if this network is a symmetrical network, means this two ratio it must be equal. Okay, if the two ratio must be equal, means that the network is called as the symmetrical network. Okay, you see, if the impedance measured at one port is equal to the impedance measured at the other port with the remaining port open circuited, means the network is called as said to be symmetrical network. Okay, so now we are going to derive the what is the condition of this symmetrical network in terms of Z parameter, Y parameter, then a H parameter and ABCD parameter. Okay, so the first one, the condition of symmetry for Z parameter. So in terms of Z parameter, we are going to derive the condition. Okay, so for that one, first you have to take the Z parameter equation. So you know what is Z parameter equation? The input voltage and output voltage, it can be written as a function of I1 and I2. So V1 equal to Z11 I1 plus Z12 into I2. V2 equal to Z21 I1 plus Z22 into I2. Okay, so this is the equation. So first one, consider figure A. Okay, so what is figure A? In figure A, the voltage V1 we are applying. You just consider the voltage V1 applied is the source voltage Vs. Okay, and we are making this output port is open circuited. So what is the output current? Output current is 0. So V1 equal to Vs and I2 equal to 0. So this is the condition for first figure. Okay, so you just substitute these condition in equation number 1. Okay, in equation number 1 we get, instead of this V1 we have to put Vs. So Vs equal to Z11 into I1 plus this Z12 into I2, it is a 0. So Vs equal to Z11 I1. So from this, the ratio Vs by I1, it can be written as Z11. Okay, so this is the thing. So next one, we are substituting the next thing. We are considering the second figure. Though in second figure, the voltage V2 equal to Vs and I1 we are making I1 as 0. So in the second figure, V2 we are applying the source voltage in output port and we are making the input port equal to 0. So V2 equal to Vs and I1 equal to 0. So substitute this value in equation number 2. Okay, since the equation number 2 is having the value V2. Okay, so substitute this value in equation number 2. So we get instead of this V2 we have to put a Vs. So Vs equal to, the first term is 0 since I1 is 0. So Vs equal to Z22 into I2. So from this, Vs divided by I1 equal to Z22. Okay, so according to the definition of symmetry, the ratio, the two ratio, the Vs by I1 and Vs by I2 both must be equal. But what is Vs by I1? It is a Z11. What is Vs by I2? It is Z22. So the condition for symmetry of two-port network is Z11 equal to Z22. That is, for example, for one two-port network, the Z11 value and Z22 value both are equal. Equal means that a network is said to be the symmetrical network. Okay, this is the condition. So in some problem, they are asking, so find the Z parameters and check whether the given two-port network is symmetry or not. Okay, so at the time you have to calculate the four value Z11, 12, 21 and 22, and we have to check the value of Z11 and Z22. If the two values are same, means the particular network is said to be the symmetric network. Okay, so that's this. Okay, then so the next one, we are going to derive the condition of symmetry for Y parameter. Okay, Y parameter. So the same thing. So first we have to take the Y parameter equation. So what is Y parameter? Admittance parameter. So the admittance parameter, we are having the two equation, the input current and output current in terms of input voltage and output voltage. So this admittance parameter is opposite to that of impedance parameter. In impedance parameter, we are writing V1 and V2, the voltage in terms of current I1 and I2. But in this Y parameter, the current I1 and I2 can be written as a function of V1 and V2. Okay, so I1 equal to Y11 V1 plus Y12 V2. Similarly, I2 equal to y21 v1 plus y22 into v2. Okay. So the same thing we have to derive. So consider the figure A. So what is figure A? So v1 equal to vs and I2 equal to 0. Okay, that is the first thing. So v1 equal to vs and I2 equal to 0. So substitute the above value in equation number 1. So in equation number 1, so I1, the equation number 1 can be written as I1 equal to y11 into vs plus y12 into v2. So we just consider this is the equation number 3. Okay, and you substitute this value. So in the previous z parameter we derived the answer in one step, but in y parameter it will take 2 or 3 steps. Since the first equation is having the value I1, vs and v2, but we want the value vs divided by I1. Okay, in this equation we have to eliminate this v2. Okay, so that's why you take this as a equation number sum number 3. Okay, and the next one, so substitute the same condition in equation number 2. So we get 0. Okay, the left side is 0. So 0 equal to y21 into vs plus y22 into v2. So instead of this v1 we are substituting vs. Okay, so from this, that is in the third equation, our aim is to eliminate this variable v2. Okay? So so from this equation we have to find out the value of v2. So let us rearrange this equation. So y22 into v2 equal to minus y21 into vs. From this v2 equal to this one. Okay, so we have to substitute the value of v2 in this equation number 3. Okay, so equation number 3 we will get I1 equal to y11 vs plus y12 into the v2 value is this one. Okay, so in this in both term vs is common, so you just take vs as common and take LCM. So y11 y22 minus y12 to 1 divided by y22 into vs. Okay, this is I1. So from this we want the ratio vs divided by I1. Okay, so the vs divided by I1 equal to this one y22 divided by y11 y22 minus y12 into y21. Okay, so this is the input impedance measured at the input port we calculated. Okay, similarly you have to consider the figure B. So for figure B, we have to apply the source voltage at the output port, that is V2 value is Vs and the input port is short circuited, so I1 equal to 0. Okay, so substitute the above value in equation number 1. So in equation number 1, this is equation number 1. So in this equation number 1 we will get 0 equal to y11 into v1 plus y12 into vs. Okay, so from this we just find the value of v1, so you have to take it as a equation number 6. Okay, but here in this case we have to find the ratio vs divided by I2. Okay, vs divided by I2. So in this equation I2 is not there, so we have to substitute the same condition in equation number 2. Okay, so in equation number 2, so the equation number 2 we get I2 equal to y21 into v1 plus y22 into vs. Okay, so here vs is there, I2 is there, so in extra v1 variable is there, so we have to eliminate this v1 variable. So already we derived the value of v1, so we have to substitute this v1 value in this equation. Okay, so we are substituting this v1 value and you take vs as common and you take LCM. Then from this vs divided by I2 equal to y11 divided by this one. Okay, this is equation number 7. So you just check the equation number 5 and equation number 7. So for the condition of symmetry, you know vs by I1 equal to vs by I2. Correct? So vs by I1 is this one and vs by I2 is this one. So y22 divided by this ratio equal to y11 divided by this one. So if these two things are equal means the particular two-port network, it is a symmetrical network. But here the denominator term gets cancelled. So from this y11 equal to y22. So this is the condition for symmetry in terms of y parameter. Okay. So in terms of z parameter, if z11 equal to z22 means it is a symmetrical network. Similarly, in terms of admittance parameter, y11 equal to y22 means it is a symmetrical parameter in terms of y parameter. Okay. Then The third one, the condition of symmetry for H parameter. Okay, H parameter. So you see, this is the H parameter equation. So the basic equation of H parameter, V1 equal to H11 into I1 plus H12 into V2. Okay, and I2 equal to H21 into I1 plus H22 into V2. Okay, same thing. So the consider figure A. So that is V1 equal to Vs and I2 equal to 0. So substitute this value in equation number 1. So we get Vs equal to H11 I1 plus H12 into V2. Okay, so we want Vs by I1, but V2 term is there, so we have to eliminate the term V2. So then try substitute the same value in equation number 2. So in equation number 2, we have to find out the value of V2. Okay, and this V2 value you substitute in the equation number 3. Okay, equation number 3, we will get the Vs divided by I1 equal to this one. Okay, H11, H22 minus H12, H21 divided by H22. That is this numerator H11, H22 minus H12, H21 is said to be the determinant of that H matrix. Okay, determinant of H matrix divided by H22. Okay, so similarly, so consider figure B. That is, we are applying the source voltage at output port and we are making input current as 0. So V2 equal to Vs and I1 equal to 0. So substitute this condition in equation number 1. So in equation number 1, we get V1 equal to H12 into Vs. Okay, and substitute the value in equation number 2. We get I2 equal to H22 into Vs. Okay, so here we want Vs divided by I2. So from this equation, Vs by I2 equal to 1 by H22. Okay, so we calculated Vs by I1 and Vs by I2. Okay, so for the condition of symmetry, this two equation must be same. Okay, so this two equation must be same. So here the denominator cancel. So what is the final answer? H11 into H22 minus H12 into H21 equal to 1. This is the condition for symmetry of H parameter. That is, what is this equation means? This equation is the determinant of H matrix. Okay, so if the determinant of H matrix equal to 1 means the network is said to be the symmetrical network. Okay, then the fourth one, the condition of symmetry for transmission parameter, that is ABCD parameter. Okay, so you just take the ABCD parameter equation. So in ABCD, you know, the input voltage and the input current can be written as a function of output voltage and output current. Okay, this is the equation. So same thing, consider the figure A, that is V1 equal to Vs and I2 equal to 0. So substitute this condition in first equation. So Vs equal to A into V2. Okay, A into V2. Similarly, substitute the condition in second equation. So I1 equal to C into V2. Okay, so from this, we just find out the value of V2 and substitute this V2 value in equation number 3. We get Vs I1 term. Okay, so Vs equal to A into I1 by C. So from this, we needed Vs by I1. So Vs by I1 equal to A by C. This is the one condition. Okay. Similarly, consider the figure B. Okay, what is figure B? We are applying the source voltage at output port and we are making input current is 0. That is, input port is open circuited. So substitute this condition in equation number 1 and 2. So the equation number 1 can be written as this. The equation number 2 can be written as this one. Okay. So from this, the C into Vs equal to D into I2. So from this, we want Vs by I2 equal to D divided by C. So we calculated Vs by I1, Vs by I2. So according to the condition of symmetry, this two value must be same. Okay. So A by C equal to D by C. So C cancelled. So A equal to D. So this is the condition for symmetry. Okay. So you just see for 4 parameters, what is this condition of symmetry? You just see in terms of Z parameter, if the Z11, Z22 value equal means the two-port network is said to be the symmetrical network. In Y parameter, the Y11 and Y22 value of the particular two-port network same now, it is a symmetrical network. Then in H parameter, the H matrix value, the determinant of H matrix is 1. That means the product H11, H22 minus the product H12 and H21 values 1 means that network is said to be the symmetrical network. And in terms of ABCD parameter, if the A value and D value is same means equal means that network is said to be the symmetrical network. Okay, so these are all the thing in order to find out the condition for symmetry. Okay, condition for symmetry. Thank you.